In this problem of the process heat transfer, that we have a 1.4 meter long and 0.2 centimeter diameter of electrical wire which extends across a room that is maintained at the temperature of 20 degrees centigrade. Heat is generated in the wire as a result of resistance heating, and the surface of the temperature of the wire is measured to be 240 degrees centigrade in steady operations. So two different kinds of temperatures are given. The one is the wire surface temperature, that is 240 degrees centigrade, and the second, the room temperature, which is 20 degrees centigrade, is given. Also, the voltage drop and the electric current through the wire are measured to be 110 volts and 3 amperes respectively. Disregarding any heat transfer by the radiation, determine the convection heat transfer coefficient for the heat transfer between the outer surface of the wire and the air in the room. Let us just try to understand this question statement with the help of a particular diagram. This is an electrical wire, and the electrical wire is being heated by the resistance heating, and as a result of this, when the electrical current is being passed through this electrical wire, and its surface temperature will increase, that is 240 degrees centigrade, and the room temperature is 20 degrees centigrade. So because of this temperature gradient between the surface and the room temperature, so the heat will transfer from this surface to the room. So the first question that comes in our mind, that which mode of heat transfer will be prominent, either the convection or the radiation. So it is particularly given in the question statement that the radiation heat transfer is being neglected. So you have to consider the convective heat transfer, and you have to determine in this problem the convective heat transfer coefficient. Let us see the solution of this problem. So before going into further detail, let us take few assumptions. That the first assumption is the steady operating conditions exist since the temperature readings do not change with time. So that's why we are considering the steady operating conditions. So the radiation heat transfer is also negligible. So we are only considering the convective heat transfer. In the analysis, we are saying that the steady operations, so the rate of heat loss from the wire is equal to the rate of heat generation in the wire as a result of resistance heating. So the first thing is you have to determine the rate of heat loss, and we have just said that the rate of heat loss is equal to the rate of heat generation inside the wire. So the rate of heat generation so the rate of heat loss is equal to the rate of heat generation, and the rate of heat generation can be calculated from the voltage which is given and the current value which is given in the question statement. So the voltage and the current values are given in the question statement after putting the values in this formula. So the voltage is 110 volts and 3 ampere current is basically passing through the wire. So after multiplying it, you will get the value of 330 watts. So this is the amount of heat which is basically generated through the resistance heating in the wire. And if we consider the same amount of heat is being lost, so this is the amount of heat which is basically lost from the wire through the convective heat transfer. So the next thing is you have to determine the surface area of the wire, right? So the diameter as well as the length of the wire is also given in the question statement, and after converting all the given units into meters, so this is the surface area of the wire pi dl, and after putting all the values you will get the value of the surface area of the wire with the certain dimensions, that is 0.00880 meter square. The next is we have to determine the convective heat transfer coefficient, and to determine the convective heat transfer coefficient we will use the Newton's law of cooling for the convective heat transfer, convection heat transfer, and which is given here, that is the rate of heat transfer is equal to the convective heat transfer coefficient, the surface area, and the temperature difference between the surface and the T infinity, which is the temperature which is far away from the surface. So we have to determine the convective heat transfer coefficient. We will rearrange this Newton's law of cooling formula, and we will take the convective heat transfer coefficient on the one side and all the remaining parameters on the other side, and we know all the values of the parameters on the right hand side of this equation, which is the convective heat transfer rate, the surface area, and the temperature difference. And we will put the values of all the parameters which we have so far, and after simplifying that we will get the value of the convective heat transfer coefficient, which will be equal to 170.5 watt per meter square per degree centigrade.